What makes you cool is your attitude,
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes. It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude,
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes.
It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes.
It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
Music make you lose control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes. It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes. It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
Not the clothes. It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.
So when doing any of these experiments, make sure that you have adult supervision with you and that you're using proper safety measures, especially when using materials such as dry ice and later on using the dry ice and alcohol mixture. Make sure that you don't touch any of these materials and that you have ways to pick up these materials without actually using your hands. And also make sure to clean up your space so that you don't accidentally knock anything over and anything like that. Just make sure you have a nice clear area to work with. Sometimes outside works really nice for some of these experiments, especially because some of them might be just a little bit messy. Also, when doing some of these experiments, especially the last one when using the gummy bears, is that you're going to want to use eye protection. So if you don't already wear glasses, you're going to want to use safety goggles or some other eye protection like that, just so you don't get anything in your eyes. Hello everyone, my name is Claire and I'm an educator here at Lowell Observatory. What we're going to be doing today is running through some pretty cool experiments that you can do at home in order to learn about our solar system. So we're mostly today going to focus on planets that are rocky, so we call these the terrestrial planets. So these include Mercury, Venus, Earth, and Mars. So these are the planets that we're going to be focusing on, and then we're going to do a little bit on Pluto at the end as well. But the first experiment we have has to do with Venus. So Venus is the second planet closest to the sun, and even though it's the second closest, it is actually the hottest planet in the solar system. Temperatures there can reach up to about 900 degrees Fahrenheit, which is really, really hot. You probably wouldn't want to go there for summer vacation. Another really cool thing about Venus is that there are many, many volcanoes on its surface. So just like here on Earth where we have volcanoes, so too does Venus. In fact, Venus has around 1,600 volcanoes. Some of them are extinct and no longer active, kind of like some of the volcanoes here on Earth, but a lot of them still are active, and astronomers and scientists study these volcanoes on Venus in order to understand how our own volcanoes work and also how planets form in the solar system and kind of what happens with that. So to get started, there's a couple materials that you'll need. So we're gonna make volcanoes, and you can use Play-Doh, which is super easy and you don't have to wait for it to dry, or you can make volcanoes made from clay. And kind of the one thing you need on top of the clay and Play-Doh is a little plastic cup or a small piece of Tupperware. We have these, but it also could be helpful to just reuse the Play-Doh tub. That's a good way to not have to buy any more materials if you'd like. And then the next two things we'll need is just baking soda and vinegar. Both of these can be found super easily at the grocery store. So we're gonna make one out of Play-Doh that kind of looks like this. I did this a little bit earlier out of a nice yellow Play-Doh, but we're gonna make one out of blue instead using the small Tupperware cup. So one of the main things to watch out for when you're making these volcanoes out of Play-Doh is that you want to make sure the Play-Doh touching the little Tupperware cup is nice and sealed so that you don't have any holes in it, so that when we actually do the experiment, it comes out of the top and not through little holes on the side, so that it's a little bit more fun that way. Kind of just a tip. So just make sure there's no holes. It's super easy to cover them up with a Play-Doh. You can kind of just keep moving the dough around. But once you think you have a good volcano shape that you want to work with, we can go ahead and add our other ingredients in order to actually make the explosion happen. So we have again is baking soda and vinegar. Now you're probably going to want to use more vinegar than baking soda. That way the reaction will happen faster and it'll be a little more fizzy so that something does actually happen. So I'm going to add some baking soda to the bottom of my volcano here. So we have a pretty good amount. And then we're going to add lots and lots of vinegar so that we can get a good reaction from this. I'm just going to pour it in here. So you can start to see it's bubbling over, and you can kind of keep adding more vinegar. You can even add more baking soda if you'd like. It's totally up to your own experimentation, but these are so easy because you can keep doing them over and over again. So you can see that we're getting more fizz, and it's a nice model to show what happens with a volcano. So a lot of this, in volcanoes, at least with Earth too, a lot of this magma is welling up outside. We can kind of simulate that with baking soda and vinegar. So that is our first experiment using volcanoes on Venus to see what happens on other planets and to kind of just learn about what's on Venus, some of the unique features there. The next planet we're going to look at is Mars. Now Mars is the fourth planet from the sun, so it comes after us, Earth. So it goes Earth, Mars, and Mars is a really, really cool planet. So as you may have heard, Earth really likes Mars. We keep sending spacecraft there, we keep sending orbital spacecraft, landing spacecraft. We really want to learn about Mars, what's on its surface, what its soil is made out of, and we want to learn as much as we possibly can about that planet. Now, some of the studies about Mars dates back to the 1890s here at Lowell Observatory. So our founder, Percival Lowell, and some of his co-workers and astronomers after that were looking at Mars through telescopes and taking pictures of Mars. And one of the first things that we found is that Mars has polar ice caps. So similar to how Earth has polar ice caps in Antarctica and in the North Arctic, basically where there's a bunch of frozen water that is covering all of that area, so too does Mars. But the one thing we needed to find out is what that ice was made out of. It could possibly be water ice, or it could be different ice made out of different elements such as carbon or nitrogen. So we really needed to figure that out in order to understand what Mars was like in the past and what it's like in the future. If you look at a picture of Mars today, one of the main things you'll notice is that there are no oceans on Mars. So there isn't really any liquid water on Mars, but liquid water may exist perhaps in the ice caps. We can do a cool experiment at home to figure out what type of ice is on Mars using a couple basic ingredients. So we're just going to use basic water. You'll need a graduated cylinder or a tall glass vase. It's better if it's clear because we'll want to be able to see what we're looking at. And what I have here is a universal indicator. The fancy word is phenolphthalein, but you can basically use any pH indicator that you have at home if you have any. You can easily get this online or at the store. And then the last ingredient that we have is kind of a special one. We're going to be using dry ice, which I keep in this cooler right here. So you can buy it at the grocery store. It comes in a bag like this. Now dry ice is incredibly cold, so you're not supposed to touch it with your hands, which is why I have tongs right here. You can use special cold-proof gloves, or you can use tongs, or you can use a cup to try and get some of this ice out. But the main thing to remember about this is that you don't want to touch it with your hands because it will hurt and it can actually burn you. So to get started, we're just going to pour some water into our graduated cylinder or vase. About this much. Then we're going to add our universal indicator. So you don't need a lot. A little bit does just fine, so we're gonna add all of it in here. And then it helps to add a little bit more water so it mixes just a little bit more. That looks good. So you'll notice when it's just water that it's kind of like this green, turquoise, blue color. And this is good. So this color means that all we're using right now is water. This, the universal indicator, how it works is that it'll look at the acidity of different objects and different materials such as water and other liquids. It'll be able to tell if it's pretty acidic or if it's basic, and it'll change color accordingly. So really what we're looking at here is what color this is right now. So the change in color is really important. So again, because it's just this turquoise color, basically the same color that we started out with, we haven't really added anything that's unique or different. Water is not too acidic and not too basic. So when we do something like this on Mars and we look at this color, we can find this type of color using a basic indicator on Mars, then we know that it's just water and water ice. But if we're gonna add something different, so let's say we're trying to find out if there's carbon ice on Mars. So we're gonna add a little bit of dry ice. So dry ice is made out of basically frozen carbon. So we're gonna add it super cold, which is why it's making that noise. But as you'll notice, it's starting to turn color, and eventually, so it's kind of orange right now, it's getting a little more pink, and it's going towards red right now as well. So you can tell that it changed color, which means that we added something different than water in here. So we know that this isn't just water ice, we know that this is carbon ice because the universal indicator will tell us that by changing its color. The reason why there's a bunch of gas and bubbles coming out is that this is super, super cold. We added it to a pretty warm liquid, water, at room temperature, and it doesn't like that change in temperature, so it's gonna start to melt really fast and sublimate, which is how we get this nice little gas. So it's kind of a fun thing to learn about, is how can we tell what ices are on different planets when we as humans can't go there ourselves and pick it up and take it back to a laboratory. We need to think of experiments that we can put onto these spacecraft in order to figure out what type of ice is there, which is something that's really cool to think about. So kudos to all the scientists who have done this, but we can create a basic experiment at home to try and figure out what type of ice is on Mars. So we know that there is water ice on Mars, and we also know that there is carbon ice. Sweet. Such a pretty color. Yeah, that's good. So the next thing we're going to learn about also has to do with Mars, but it can also extend to other bodies in our solar system, including Earth and our moon. So when you look up at the moon in the night sky, what you might be able to find through a telescope or even with your own eyes are these small little circles on its surface. These are called craters. So craters are something that happen to every planet that we can see on every planet in the solar system. So when we look at Mars, we'll be able to notice these nice big circles on its surface, and these are caused by other bodies such as smaller rocks that are hitting the surface of Mars and creating an impact site, which is also what we call craters. So we're going to kind of explore how that happens and what happens to the soil around craters with a cool experiment using just flour and cocoa powder and some rocks that you can find outside, or some marbles or round hard objects that you can find in your house. Really, you can drop anything into this. So kind of what we're gonna need is like a nice big baking pan like this. You can also use a like thicker, wider Tupperware that you use to store other things in. And you're just gonna fill most of it with flour. And then at the very top, if you can kind of see here, we have just a small dusting of cocoa powder on the top. Basically just like the top layer on top of the flour. So in terms of Earth, that dark stuff would probably be more like the thin layer of crust on top, and the flour underneath would be smaller layers under that. So this one is super easy. All we need to do is set this up, and then we're just gonna drop something on top. So what you'll notice is that, yes, there's a lot of stuff that's flying around. So when we drop the thing in, a lot of this material flies up. And we can actually notice this happening when we watch impact sites on other planets. And if we look at the moon, we can actually see all of this material that has been ejected out. But if we take the marble away, what you'll be able to notice once we do this is that you'll be able to see the white flour from underneath the cocoa powder, which is what happens when you drop something heavy on the surface of a planet. It'll kind of bring up some of that older material in lower layers underneath, which was cool for us to be able to study so that we can understand what happened to Mars in the past. With these unearthed layers, we can kind of tell what Mars was made out of when it was younger, what it was like when it was younger, and we can apply that same principle to all of the other planets in the solar system. So this is a really cool experiment to be able to just figure out how cratering happens, what happens when a meteorite hits Earth, and other things like that. So we're just gonna drop a marble in. We can do it again, and you can throw it harder or drop it lighter to create different effects. And you can also do smaller ones as well. Or you can use bigger objects such as like a tennis ball or one of these like this. Make bigger ones.
Nice.
Okay. So the last planet or dwarf planet that we're going to learn about is Pluto. So Pluto was discovered at Lowell Observatory back in 1930. But Pluto is 3 billion miles away from the sun. So if you can imagine being that far away, you're going to be really, really cold. In fact, Pluto reaches about negative 400 degrees Fahrenheit, which is colder than basically any spot here on Earth. So in order to really understand how cold that is, we're going to do a cool experiment making liquid nitrogen that you can make at home, but using different materials than just liquid nitrogen. So what we're gonna be using is we're gonna be using a little bit of isopropyl alcohol and the rest of our dry ice here. So again, the dry ice is extremely cold and you can't touch it with your hands. So you always have to use some sort of tongs, a cup to scrape it, or gloves that are approved for handling extremely cold materials. So in order to make the fake liquid nitrogen that we're going to be able to use, essentially what we're trying to do is make a really, really cold liquid that we can put other things in. So we're going to add big chunks of the dry ice, and you can start to see it's going to bubble up, which is kind of fun to watch too. But it'll definitely take a little while for this to get a little bit cold. But it's kind of just to show you how that's going to happen. Add one more piece. So once it stops bubbling, usually that's a good indication that it is at a cold enough temperature for us. So I'm gonna go ahead and put that back. So we're gonna put this to the side, but you can start to see the dry ice is bubbling, similar to what happened when we did our Mars experiment, but this time it's just an alcohol. So in here, we have the same thing, but this time we added gummy bears. So the reason why we did this is because here, gummy bears on Earth are nice and gummy. You can squish them. But if we were to put these gummy bears on Pluto, something very different would happen. So these gummy bears, because they have been in such cold temperatures, similar to what Pluto would be like, are gonna be really hard and brittle. In this vase, I have my already prepared gummy bears in here, and this is the sample one, so this just has isopropyl alcohol and a couple chunks of dry ice. And what you're gonna do is you're just gonna drop a couple of the gummy bears in here and let them sit there for at least a couple of minutes. But it does take a little while, so we're gonna use the ones that I already made in here. Gonna stir them around a little bit. So here's one of the hard gummy bears. You can tell even just dropping it on the table that it's gonna be pretty tough compared to the other gummy bears. So we can usually smash these. It might take a couple of tries, but you're just gonna wanna go really hard and in one direction. Flew off the table, but it's okay. We can keep doing this. It's definitely harder than I thought. Okay. Oh my gosh. Yay! Okay, that worked. Alrighty, so today we have looked at volcanoes on Venus, we have looked at cratering in polar ice caps on Mars, and we have looked at the temperatures of Pluto. So don't forget, when you're doing any of these experiments, please make sure to have an adult with you and that you're using proper safety controls and materials. But I hope you guys have fun, and tag Lowell Observatory in any experiments that you do, and have a good time doing science. So when doing any of these experiments, make sure that you have adult supervision with you and that you're using proper safety measures, especially when using materials such as dry ice and later on using the dry ice and alcohol mixture. Make sure that you don't touch any of these materials and that you have ways to pick up these materials without actually using your hands. And also make sure to clean up your space so that you don't accidentally knock anything over.
What makes you cool is your attitude.
Your inner self.
It's not the way your hair is cut. It's not the clothes you wear.
Not the clothes.
It's not what you drink.
You got that right.
You got Pepsi for me?
Who knew?
Music make you lose control.
Rock a showstopper, beats get it crunk and wired. Wave your hands, scream loud. Everybody here get it out of control.